Hello, welcome to lesson 10.2, Fundamental Counting Principle. So this is our second lesson in probability. Last time we made tree diagrams to find what the possible outcomes of events were. And this time we don't have to make any tree diagram. We don't have to write out the outcomes. We're just going to find the number of outcomes. And something called the fundamental counting principle makes that very simple for us, because basically we're going to be multiplying to find the total number of outcomes. So technically it says if event M has n possible outcomes and event N has n possible outcomes, then event M followed by event N has m times n. So basically, yeah, we're just gonna know the number of possibilities for each event and multiply that number. And you can see this you can see this example later, but let's just dive into example 1. So it says a basketball player attempts a shot that can result in a score or miss. So how many events are happening? Just one. It's just attempting a shot is the event. And the possibilities are the score or the miss. So there's just two outcomes, two possibilities. So the answer is 2. So go ahead and pause, try number 2 by yourself. And again, we have just one event here. It says a room in a house needs to be painted. So just one room is being painted. That's the event. So what are the possibilities? So it could be either white, gray, or yellow. That is the 3 possibilities. So our answer is 3 outcomes. So now we're going to be, each time adding another layer of complexity here. So now we're going to have 2 events for 3 and 4. So 3 says a sandwich shop has 4 types of sandwiches: ham, turkey, chicken, and PB&J. Each sandwich can be ordered with white bread or multigrain bread. And we actually had this one from last lesson, but instead of writing, or something very similar, but instead of writing the tree diagram, we're just going to be, and writing out all the outcomes, we're just finding the number. That's all it's asking, is the number of outcomes. So how many events is it? Well, we can choose the type of meat, okay? And then I'm actually going to use you don't have to use a different color. I'm just going to show you that the second event is bread. And let's use black in the middle. So we're going to be multiplying the options for meat, and then we're going to be multiplying that with the number of options for bread. So how many meat choices? Well, there's ham, turkey, chicken, and PB&J. That's 4. Times, let's make that black like I was trying to do. There we go. All right, and how many options for bread? So there's white bread and multigrain bread. That's 2. So all we're doing is multiplying 4 times 2 to get 8. Okay, so now go ahead and pause the video. Try number 4 by yourself. Remember, you find out or decide what the events are first, then find out the number of outcomes for each event, and then you're multiplying. So go ahead and try number 4. All right, so it says for number 4, a spinner can land on either red, blue, or green, and you spin twice. So this time we actually don't need different colors because you'll see in a second. But if you spin twice, the first event is just spin number 1, and then the second event is spin number 2. Okay. And then the possibilities for spin number 1 are red, blue, or green. That's 3. And it's the same thing for spin number 2, right? Red, blue, or green times red, blue, or green. So that is 9 different outcomes. Again, if you think about what we did last time with the tree diagram, that's all we were doing was multiplying. Those branches were multiplying. Like red, blue, or green, each one of those had 3 more options. So that's why you get 3 times 3, which is 9. So now we have, 5 and 6, still adding in just one more layer. I think we can have up to maybe 3 events, I think we go up to. So let's look at number 5. A jewelry store sells gold and platinum rings. Each ring is available in 10 styles and is fitted with one of 8 gemstones. So what are the different events here? So we have the gold or platinum, which we'll just say is the band of the ring. Oh my goodness. There we go. So that's Oh my goodness, I'm trying to do the colors and it's not working. So we have the band of the ring. Then it says each ring is available in 10 styles. So we have the style of the ring. And then let's choose orange. And then we have the gemstone of the ring. Okay, remember, you don't have to do colors. I'm just trying to show you. These are 3 different events, right? We have the band of the ring, we have the style of the ring, we have the gemstone of the ring. So that's what we're going to be multiplying. So how many different band choices do we have? Gold and platinum, that's 2. How many different styles do we have? It says each ring is available in 10. So that's 10 styles. And then we have the gemstones, which would be 8. Okay. And we're multiplying all of that together. So 2 times 10 times 8 is equal to.
Ms. Hurst, Mr. Erickson, please dial 4102.
Okay, and you can always use a calculator, but 2 times 8 is 16. 16 times 10 is 160. So you have 160 outcomes for that event, or those 3 events. So now go ahead and pause for number 6. Try number 6 by yourself. Do the events first, then the number of outcomes for each one. All right, so we have the chess club must decide when and where to meet for a practice. The possible days are Tuesday, Wednesday, Thursday. The times are 3, 4, and 5 p.m., and there are 8 classrooms available with a number of possible outcomes in the sample space. So our first event is the days that they can meet. Our second event is the times, and then the third event is the classroom, the room. Okay, so once I've decided those, now I can decide now how many outcomes. So how many different days do we have to choose from? There's 3 days. How many different times we have to choose from? There are 3 different times, right? 3, 4, or 5 p.m. And then how many rooms? It says 8 classrooms. Okay, so we're going to multiply these together. So 3 times 3 is 9. 9 times 8 is 72. All right, so now we have done 1 event, 2 events, 3 events. What happens if there's more than 3? I said there's 3 is kind of like the max with these type of problems, where we're just going to be multiplying each number. But there might be more than 3, in which case we're going to be using an exponent. So I'm sorry if I misspoke there. We could have more than 3 events. If it's basically more than 3, we're going to be using an exponent. Let's write that. More than 3 events. Because we don't want to keep, we could write, each event and just keep writing it like I showed here in this example, but why do that when we could just use an exponent? So basically the base is going to be the number of possibilities. Let's actually put that. So number of possibilities is going to be the base, and then the exponent is going to be the number of events, okay? And that should make sense because the possibilities, right, that's what we're always multiplying. And the number of events, that's how many times we're multiplying it. So let's look at number 7. It says you flip a coin 12 times, find the number of possible outcomes in the sample space. So if you're flipping a coin, how many possibilities is that, right? It's just heads or tails, so that's 2. You're flipping it 12 times, so our exponent is going to be 12. And we use the calculator. So we're going to put in 2, then the exponent key is that 5th button down, and then the 12. Hit equals, we should get 4,096. If you're not sure what button I'm talking about, it looks like this. I'll draw it for you. This is the exponent key. It's like this, a little, almost like a little arrow going up. All right, so go ahead and try number 8 by yourself. All right, so the football player attempts 6 passes in overtime. Each pass attempt results in a completion, incompletion, or turnover. So how many different possibilities do you have? Well, completion, incompletion, turnover, that's 3. So 3 possibilities. And it says 6 passes. So that's the number of events that's happening 6 times. So it's going to be 3 to the 6th power. So again, grab the calculator clear, put in 3 to that little exponent button to the 6th power, and we get 729. All right, that is the end of this lesson. If you have any questions, please let me know. Otherwise, go ahead and try the practice, and I will see you in the next lesson. Bye.